Astronauts have stated that when looking at Earth from space, the only indication that the planet hosts intelligent life is the lights that illuminate the night sky. If it wasn't for these lights, the Earth would look like any other planet in the universe from a distance. Astronomers speculate that we could detect other planets in the cosmos that may host intelligent life by looking for signs of artificial lights on their surface. Reports state that the newly launched James Webb Space Telescope could help us detect artificial light on certain planets. Let's take a closer look. The JWST is a state-of-the-art space telescope that is a culmination of 30 years of research and development costing $10 billion. Calling it one of the grandest scientific endeavors of the 21st century wouldn't be a stretch, as it represents the future of space observation and one of the observatories we will rely on the most to increase our understanding of the universe in the coming decades. The telescope will have the capability to see just about anything in the sky, but its main objective will be to observe light coming from the very first stars to shine in the universe. This will make it possible for us to see the moment when darkness ended and the first stars came into existence for the first time. Because of the complexity of the equipment, the James Webb Telescope has had to sit through various delays in development, but now that it is operational, it will help us answer some of humanity's greatest mysteries. Having the ability to accurately trace sources of light millions of miles away is one of the biggest reasons why the telescope may be the first piece of equipment in history to finally discover traces of intelligent life in the universe. And as Proxima b seems to be one of the leading candidates to host an alien civilization, the telescope may be our only hope for finding answers. The first clue of the possibility of intelligent life on Proxima b was discovered back in 2019 when a strange signal was picked up coming from the direction of the planet by the Parkes Radio Telescope in Australia. Although the reports are still a bit unclear, the signal reportedly showed up during 5 different 30-minute periods over several days while the telescope was directly pointing towards the planet. Based on the information available so far, the signal was concentrated into an extremely narrow range of frequencies. This pointed toward it being artificial and distinctly unlike any known natural radio sources. One of the biggest lingering questions at stand is, if the signal does turn out to be of extraterrestrial origin, should humanity send them a reply or not? However, our technological limitations mean it would take just over a decade for the message to reach the planet. The next step in this discovery is to identify all possible sources of terrestrial interference in the data collected from the strange signal. Since such a massive discovery will change the course of human history and our understanding of the cosmos forever, the scientists involved are rightly taking every step necessary to correctly identify the origins of this signal. For centuries, fictional depictions of planets orbiting other stars have fired our imagination. From the desert world of Arrakis and Dune, to the lush jungles of Yoda's planet Dagobah in Star Wars, we humans have been fascinated with the idea of exotic, far-off worlds. We now know that worlds beyond our solar system, known as exoplanets, do exist. In fact, there are a whole lot of them. Scientists have found over 5,000 exoplanets and think that most stars have their own solar systems. Some exoplanets are surprisingly similar to fictional worlds we've imagined, while others have turned out to be more exotic than anything we could have dreamed. Our universe is estimated to have over 100 billion galaxies, each with hundreds of billions of stars. If most stars have one or more planets around them, there may be billions of trillions of planets in the universe. Every exoplanet discovery teaches us something new about how the universe works. When we just had our own solar system's 8 planets to study, we had a limited view of what kind of planetary systems are possible in the cosmos. Now, with over 5,000 exoplanets cataloged, the horizons of planetary science are broader than ever. We also sometimes get to see other solar systems forming, which teaches us about our own origins. It's like watching our very own How It's Made show through the world's telescopes. There are lots of reasons to learn about exoplanets, but perhaps the most compelling is that we could find another world that hosts living organisms. If we discover life beyond Earth, it could change the course of human history. And with continual advancements in exoplanet research, this discovery could happen in your lifetime. Even when looking through a powerful ground or space-based telescope, stars look like tiny points of light. planets are even tinier and very difficult to spot next to their bright host stars. Therefore, scientists rely on indirect methods, like looking at the stars themselves for signs that planets might be orbiting them. As these techniques have evolved, we've gone from merely being able to tell if a star has a planet to being able to detect characteristics of exoplanets. Through increasingly sophisticated technologies, we can not only figure out basic exoplanet traits like mass and diameter, but whether a world is solid or gaseous, or even has a water vapor in the atmosphere. A new NASA mission called the Roman Space Telescope is an astrophysics and exoplanets mission that could launch as early as 2025 and will be able to detect Earth-sized rocky worlds. One of the main goals of exoplanet research is to find planets that resemble Earth. You'll often hear the term Earth-like used to describe worlds that resemble our own. Generally speaking, this means the planet might have liquid water and an atmosphere that could support life as we know it. Life on other worlds may be unrecognizably different from what we know here on Earth, and even life on our planet is extraordinarily diverse. But it makes sense to start by looking for worlds that resemble our own. When viewing the Earth from space, the most obvious sign that a civilization calls the planet home is the glow of lights from the night side of our planet. The massive cities which are visible from above emit light that is shed into the cosmos. The biggest problem we have had so far is the lack of technology to observe similar lights on planets outside our solar system, but this will all change thanks to the James Webb Telescope. Since the Proxima b is tidally locked with a permanent night side, scientists speculate that any intelligent civilization living on the planet may deploy powerful mirrors or use very bright LED-style lights to illuminate their cities. Just like Earth, the light from these cities will undoubtedly rise into space, where we may be able to see them for the first time. The new telescope has a wider spectrum view than any of its predecessors and will operate further out from the Earth in a solar orbit of 930,000 miles from home, and will have the ability to detect these lights. Initial investigations have already been carried out to estimate if artificial lights can be detected on the dark side of Proxima b by computing light curves from the planet and its host star. The two different scenarios which could occur are artificial illumination on an identical spectrum as LEDs on Earth, or a narrower spectrum that leads to the same proportion of light as total artificial illumination on Earth. If the telescope can detect the narrow band light that is similar to LED bulbs, it will be because of its ability to characterize the atmosphere of the planet. This will allow researchers to use various instruments to detect how much energy transport takes place on the planet, and then perform calculations of light curves to determine whether they match those of an LED light source. If this is indeed the case, then we will be one step closer to concluding if Proxima b is a bastion for life outside our solar system. The possibility of remotely detecting biosignatures has been a hot topic in recent years. In our own solar system, the recent discovery of phosphine in Venus's atmosphere sparked speculation that the chemical might be created by a microbial life form. Similarly, remote sensing experts have proposed that plant life, which uses photosynthesis for energy, could be detected in infrared wavelengths as chlorophyll absorbs visible light that shows up brightly in infrared and would give planets covered in foliage a distinct red edge. A single pixel photo of a distant planet just might contain enough information to tell us if biological life is there, based on the information stored in the wavelengths of light that reach the telescope lens. But what about intelligent life? Could JWST detect civilizations similar to ours? How would we look for them? The best answers come from understanding what humanity's presence on Earth looks like from outer space. We give off waste heat and artificial light at night, but perhaps most significantly, we produce chemicals that fill our atmosphere with compounds that wouldn't otherwise be present. These artificial, atmospheric constituents just might be the thing that gives us away to a distant alien species scanning the galaxy with their own powerful telescope. A recent paper examined the possibility of using JWST to search for industrial pollutants in the atmosphere of exoplanets. The paper focused specifically on chlorofluorocarbons, which, on Earth, are produced industrially as refrigerants and cleaning agents. CFCs infamously created a massive hole in Earth's ozone layer in the 1980s before an international ban on their use in 1987 helped reduce the level of CFCs back to less harmful levels. These potent greenhouse agents with long atmospheric residence times, if found elsewhere in the galaxy, are almost certain to be the result of a civilization capable of rampant industrialization. In other words, some of humanity's worst byproducts, our pollution, may be the very things that makes us detectable. And it means that we may be able to find other species capable of treating their own planet's atmosphere with the same disregard. There are some limitations to JWST's CFC finding capabilities. If a planet star is too bright, it will drown out the signal. The telescope will therefore have the most success by looking at M-class stars, which are dim, long-lived red dwarfs. A nearby example is TRAPPIST-1, a red dwarf 40 light-years away with several Earth-sized planets orbiting within its habitable zone. JWST would be able to see CFCs on TRAPPIST-1's planets because the dim star won't drown out the CFC signature in the same way that a bright star like our Sun would. Conversely, a JWST-like telescope at TRAPPIST-1 wouldn't be able to see Earth's CFCs. Our Sun is just too bright. Unfortunately, M-class stars are not usually conducive to life because when they are young, they are unstable, sending out powerful solar flares that might just exterminate any nascent life on nearby planets. They do, however, tend to calm down as they age, so it isn't an impossibility. It just means that we should temper our expectations a bit. Whatever we find or don't find out there, the fact that we are about to have the capability to look at all is a game changer. If you like this video, please consider taking a look at this one, which talks about the JWST and how it may have detected water on a distant planet. Do you think an intelligent civilization is capable of detecting artificial lights from Earth? Please share your thoughts in the comments section below.